Today on Home Built Workshop, we're gonna have some fun. We're playing with a bass guitar, but not just any bass guitar. This bass guitar. This is an Epiphone Bass. It's basically a P-bass copy that I picked up super cheap off a marketplace. The reason it was super cheap is because this, well, let's just say unattractive batwing headstock is broken. But as far as I'm concerned, that's not a problem. I could fix that, but we're not going to. I'm going to remove this neck, and in this episode, we're going to build an entirely new Haley Guitars P-bass style replacement neck to replace this thing and get this relic back up and running. Should be pretty fun. Don't worry, I'm not going to throw this neck away just in case we need it later on, but we are going to make an entirely new replacement neck. Let's get started. I'm Jeff. You're watching Home Built Workshop. Stick around. Let me know down below if you like that headstock. I'm not a fan. I think we'll just jump right in, pull this old neck off, get it out of our way. Now, this project is not something that just popped up out of the blue. This is a build that I've been planning for quite a while, but I needed to find some sort of a guitar project that has a P-bass style neck pocket, or a J-bass, I guess, too. I don't own either a J or a P-bass style bass. So when I found this one on Marketplace, I think it was about a perfect find. Ooh, squeaky. As far as I can tell, all the dimensions match up for a P-bass style neck. For a little while now, I've been wanting to create my own style of replacement necks, but I just haven't had quite the right project come up. And I think this, since it needs a new neck anyway, is a perfect project to allow me to take the time and finish the design and the development, get everything worked out to make my own necks. I've been spending quite a bit of time behind the scenes over the last few weeks, maybe even month, working on designing my own neck. And I think I've got it all worked out. I'm going to do a lot of this work using my CNC machine because, well, if we launch this as replacement parts, it's going to need to be repeatable and accurate to produce. And the CNC machine is going to allow it exactly that. Now, on the back of this neck, the only thing I can find that sort of helps identify this is a little sticker down here, and it just says Accubase-JR/VS. That is all I know about this. No serial number that I can find. There is a little bit of a light area here, which sort of tells me that there was probably a sticker there with the serial number. That's why I hate stickers for important things like serial numbers. It should be stamped into the wood or something like that, not just a sticker that you can peel off. But anyway, we got us an Accubase here with a cracked headstock. Let me bring in a little bit closer and see if I can show you this crack before we get started on making the replacement. Trying to have this pointed where maybe a reflection will show up. If we look right in here, there's a crack that runs all the way down, goes down to at least here. Maybe it jumps over to the next tuner, but then I can see another crack here. And I think it might stop at this tuner. Now I probably could remove these tuners, which we'll do anyway. I'm going to reuse these tuners. Probably could pull that open a little bit, squirt some glue in there, work it in, and glue this up to make this headstock solid again. But again, that's not the point, and that's not the reason I picked this up. I want to make my own neck. But like I said, I'm going to keep this just in case maybe somebody later on wants to fix the original neck and put it back on. One other thing that I want to show you before we get started is how absolutely terrible this neck pocket fits the neck. Now, it doesn't need to be super tight so you can pick it up necessarily by the neck joint, but that is really loose. Look at all of that play. Our replacement neck is going to be a lot tighter, and some could argue that that affects tone. Now, don't take that out of context and say that I made the wild claim that neck pocket fit affects tone. I like a solid neck pocket fit, but I can neither confirm nor deny that it makes any difference with how your guitar sounds. I'd love to hear your thoughts on that though, down below in the comments. Should be fun. So before we get started cutting some material, I want to take a couple measurements just to confirm that my design is close enough to work with this. Yeah, we're about 2.5 inches, just under 2.5 inches in width at the heel. And this is just over 1.5 inches. So it's about a J-bass neck. J-bass is a little bit narrower than a P-bass. So we're about 1.5 inches. That's pretty much standard J-bass width. 2.5 inch wide heel, actually just under here, but I'll bet our neck pocket, just some rough measurements again. Our neck pocket is much closer to 2.5 than this. So I feel pretty comfortable that this is basically a Fender style neck pocket, and that's what the neck I've designed has. To make my replacement neck, I'm going to use hard maple. Hard maple makes a great solid neck. This is a piece that I've already thicknessed to 3/4 inch, which is where I like to start. By the time you add a 1/4 inch fretboard on there, that gives us a final thickness of 1 inch, which is very standard for a sort of Fender style neck. This piece is going to work awesome. So now we just need to throw this thing on the machine and out pops a finished neck, right? At least that's apparently what some people feel like a CNC machine does. While we're working through this process, hopefully it's my goal to try to show you some of the behind the scenes work that needs to happen in order to make something like a guitar neck on a CNC machine, because believe me, you don't just load this on the machine and out pops a neck. It's not how it works. There's a lot more that goes into it. Before we jump into the behind the scenes stuff though, I want to get this loaded up on the machine and start making some cuts. It takes quite a few hours to make all of the different cuts, so I want to get that started now. That way it won't take quite as long, and then I can show you the behind the scenes stuff. So let's load this thing on the machine. I have a center line that I've drawn out on this piece of wood. I'm going to line that up with the center line that I have on my wasteboard here. That way I'm going to get the grain orientation that I want once we're done with this entire neck. Once my center lines are perfectly lined up, I'll use these hold downs to clamp my hard maple board in place. That's not going anywhere. Now I'll use my touch probe to set the position of the machine. This is the only time of this entire process that I'm going to be probing the X and Y axes. So instead of probing with the cutting bit in the machine, I've got a 1/4 inch precision ground gauge pin installed in place of the cutting bit. This keeps things as accurate as I can possibly get it. From here on out, the only thing that I'm going to be changing is the Z height as I change bits for different operations. All of my cuts are going to start from the same X and Y position. What you're seeing the machine do right now is it's simply drilling dowel pin holes at each end of the stock. These are going to allow me to pin the piece of stock in place and make sure that it maintains its exact alignment as I flip it over. With the dowel pin holes complete and my stock firmly registered into place, I can now begin the first cuts for creating our new bass guitar neck. My next operation, and the operation you're seeing right here, is to cut the truss rod channel as well as slots for the 2 carbon fiber rods. Why don't we just let the robot do its job for a little while? It's going to take a few minutes, so now I think it'd be a good time to start diving in a little bit deeper into some of the behind the scenes stuff of what you need to do and what you need to know before you can begin building a guitar or even a neck on a CNC. Well, before you can do any of that stuff, you need to know some software. There is a wide array of software out there on the market, and you can use whichever one you want. Just do your research. If you're brand new and you're just getting started, but your end goal is to be able to build guitars on a CNC, you got a little bit of homework to do ahead of time. You need to choose your software, spend the time to learn how to use it proficiently. Now, do you have to be a whiz? No, you don't, but you need to be pretty comfortable with that software before you can even begin thinking about designing and building guitars. I spent hours and hours and hours using my chosen piece of software just to get familiar with all of the functions and how they work before I even started designing a guitar. Then, once it came time to building the guitar, there was many, many more hours spent designing that thing, trying to get everything right, because, well, turns out that there were still functions that I needed to know that I hadn't used yet. I thought I was proficient with the software, but I didn't find that out until I actually dove in head first and started designing a guitar. It takes a lot of time to really get proficient before you can even begin cutting the wood. So just be prepared to spend the time. It's kind of fun. It's a little bit frustrating at times, but the end result is worth it, especially if you're looking to build guitars with a CNC. I think the truss rod channels are all cut, so let's head back to the machine. We're gonna flip the piece over on those dowel pins, and then we can start cutting the back shapes for the neck. Now I can start my set of operations on the back of the neck, the first of which will be to drill the tuner holes, and then I'll begin cutting the back contours of the neck. The first operation is a roughing pass. This is designed to just remove the majority of the material. Once most of the material is removed using just a normal 1/4 inch straight cutting bit, I'll switch over to a 1/4 inch ball nose bit, and we'll use this parallel pass with very tiny step overs to fine tune and remove the rest of the remaining material. And it's at this step that the final shape of the neck starts to really show through. Now we're not done yet because I did leave some material here. We'll have some hand shaping and of course sanding to do, but overall this profile is looking really nice. So again, we're gonna let the machine just run. It takes quite a while to make all of those cuts because I'm using very small step overs. So we're just gonna let the machine go. And I got another thing that I wanna point out that's gonna take up a little bit of your time. At least it's something that I feel should take up a little bit of your time. So once you've learned your software and you've got your model finally designed, well, now it's time to put it to the test. And that's exactly what I recommend is testing. Test on scrap. You've probably heard that before when it comes to finishing, stuff like that. Well, I think it's exactly the same when it comes to using a CNC machine, well, to build just about anything, but especially guitars where you might potentially be using some more higher end materials. Believe me, it's a huge drag when you throw a piece of rosewood or mahogany or something on there and you accidentally forget to set a 0 or you forget to do something important and your piece gets destroyed. Been there, done that. That's a drag. Before you load any good materials on there, I cannot stress enough how important I think it is to test. Test your cuts, test your processes, test every single thing. You want to check everything. Check all of your measurements, your depths. Make sure everything is turning out exactly the way you have it designed. As long as your machine is set up properly, if you have something set to a certain dimension in your software, you should be getting that exact same dimension. Don't assume that a little bit off is okay. There's a reason that something could potentially be a little bit off, and you want to figure that out now before loading on your good material. I have probably done 15, maybe 20 different tests, from simple tests of the truss rod channels just to make sure they are exactly perfect, to really full necks, including fretboards, fretboard markers, all of that. I want to test everything. I highly recommend using some sort of inexpensive material. This is stuff that I really can't use for anything else. I thought it was going to be great stock, but once I got it milled up with the chainsaw mill, I found out that it really wasn't all that great for normal projects. But for this, even with cracks and splits, it is incredible. Because, well, it's basically free, cheap test stock. So I'm not too worried about burning through a lot of pieces. You got to do your testing. And that's probably going to take you a little bit of time, especially because these ones here where I have the entire neck all in, it takes about, I don't know, a day day and a half by the time you wait for glue to dry just to do one. So depending on how in-depth you're getting, the testing process could definitely take some time, but it is one that I highly recommend you do not skip because very important. I want to do enough testing so that when I put good material on the machine, I already know that my process is solid and things are going to turn out exactly the way I have it designed. Let's head back over to the machine real quick, and our last process for this particular setup is going to be to just cut out this shape. The back will already be contoured, but we're going to cut that out, releasing the stock from the waste material around it. With the piece cut free, we can now remove it from the wasteboard. Here's a quick shot of the back. So far everything looks really good, and if we look at the front, you can see that the actual neck blank still held in place by a few wooden tabs. I'll cut those tabs quick and easy just using one of these little cordless oscillating tools. And there's our rough-shaped neck blank. And now, guess what time it is? It's time for our first little bit of sanding. We got a lot more to do later, but right now, I just want to spend a little bit of time with a sanding block and clean up the areas of the neck where those little tabs were. I want to make sure everything's nice and flush and all the edges are smooth. On this neck blank, I have the truss rod slot as well as the channels for the carbon fiber rods cut, but if you've seen any of my guitar builds, you'll know that I use a heel adjust truss rod. So that means we need an access hole right here in the end to accept the nut on the truss rod. But how are we going to do that? Well, that's easy. Seeing as how I have this modeled up digitally, it's super easy to just make another model for a 3D printed truss rod drilling jig. This thing works super simple, printed out of, well, I don't know what color we'll call this. Fuchsia? I don't know what that is, but it works great. This little contraption fits the heel of my neck perfectly. And here in the end, we have a drill bushing, which helps keep the drill bit nice and straight. And that way, it doesn't wander from side to side. Thing holds it right in place, and we can drill the access hole for our truss rod exactly where it needs to be. Yeah, another awesome use for 3D printing for guitar building. If you don't have a 3D printer, I highly suggest that you consider getting one. This little jig is super simple to use. I just press the neck in place. It's held in by friction because it's a nice snug fit. And then we'll just use our drill bit through the drill bushing to drill the access hole for the truss rod nut. Now we'll drop our truss rod in place. And that fits perfectly. Just a fraction below the surface, I can feel it with my fingernail. Now we can drop in our carbon fiber rods. That's a nice fit right there too. We're ready to glue on a fretboard. Before I apply any glue, I'm just going to lay the fretboard in place, flip this whole thing over, and then I'll just trace out roughly where that neck is going to go. There's a little imperfection in this piece of material right here. I want to make sure I'm avoiding that. And down at the end, since this is going to have a fretboard overhang, I need to make sure that I'm leaving enough material there as well. So I'll just trace that out. Now you've seen me glue on fretboards before, and I'm sure you've watched several other builders glue on fretboards, and you've probably noticed that everybody seems to do things maybe a tiny bit different. A lot of people will mask off the area around the truss rod in an effort to keep glue out of there. Well, I've done that, and I think that that's a perfectly acceptable method. There's absolutely nothing wrong with it whatsoever. But one thing that I feel is that, well, once you apply the glue and you clamp this up, you're still going to get squeeze out that could potentially work its way in. Some people will tape over the truss rod and then remove the tape when they're done. I have seen people that will end up leaving the tape in place, and I think really that's about the only method that really is going to keep any glue out of that truss rod. But also, the way I see it, there's really nothing in here that's going to get affected by a little bit of glue squeeze out. Now, I do try to be very mindful of how much glue I'm applying. I don't want a ton of glue right in the middle because I don't want excessive squeeze out. But I also don't worry a whole lot if some glue gets near the truss rod channel. To clamp this in place, I've made up a clamping caul that's the exact profile of my neck. During this process, of course, it's very important to work quickly. Try to have your clamps ready ahead of time. Mine are right at arm's reach, so I can just reach over and grab them. But if you've got them stashed away somewhere, pull them out before you apply any glue. Because once you get glue on there, you do want to get this thing clamped up as quick as possible. Always like to use cauls. I highly recommend using clamping cauls rather than trying to clamp right down on your piece. All right, there we go. We'll just give this a little bit of time to dry. So after gluing on our fretboard, here's what we're left with. A little awkward, weirdly shaped. We got a little bit more work to do. Our next step is going to be to load this back onto the CNC machine, and then we can actually make this actually look like a neck. But this video is getting a little bit long, I think. So right now, probably is a good spot for us to wrap up this. Let's call it part 1 of the replacement bass guitar neck build. That's a mouthful. We need a better name than that. But anyway, make sure you hit that subscribe button if you're not already so that you get notified when part 2 comes out. Hopefully you enjoyed this. We're going to make this a little mini series, I guess, probably a 2-part video. In the next episode, we'll finish cutting it. We'll do all the final sanding, fitting, and also the finishing and fretwork. So make sure you stick around, stay tuned for that episode. Thanks a lot for watching, everyone. I appreciate you, and we'll see you next time. It's not comfortable to play yet.